Hi, this is Faris and this will be Chem Week 3. Which of the following are not properties of noble gases? Now what we know about noble gases, they are stable and their melting and boiling points increase as we go down the group. So, they exist in nature in the monoatomic state, yes, because they don't react with anything. They are inert, yes. Their melting points and boiling points, they don't decrease, they increase, so wrong. And they belong to column 18, yes. They are highly reactive, wrong. Which of the following statements best explain why hydrogen is a diatomic gas? Again, this question was in the last week's quiz. When the hydrogen bond, each hydrogen nucleus feels like it has two electrons around it, like helium. So, when each atom share electrons, each one feels two electrons around it, yes. When each atom share electron, each one feels 8 electrons, no. It is stable like chlorine. Chlorine is not stable أصلا. It's stable like helium, yes. When each atoms transfer, immediately transfer is wrong. They share, not transfer. Which of the following best explains the existence of stable H2O molecules? Again, when they bond, the O has 6 valence electrons. After it shares 2 with the hydrogen, it's going to feel like it has 8 valence electrons, so 10 in total at the inner shell. So O is going to feel like it has 10 electrons, like neon. H is going to have feel 2 like helium, and they both achieve the configuration of the nearest noble gas. Each H feels 8 electrons, no, not 8, so wrong. And both atoms H and O achieve the number of electrons of halogen gas, no, not halogen noble. Okay. The chemical formula of silicon hydride is, now we know silicon is in group 4. Group 4 only shares, and hydride, hydrogen, is a non-metal, so there is going to be a covalent bond. المهم, silicon, it needs 4 electrons to be stable, and each hydrogen can only share 1 because it already has only 1 أصلا. So it can only share 1 because it also needs 1. So Si needs 4 and hydrogen needs 1 and can only share 1. So how many hydrogens do we need to fill all of the spaces for Si? We need 4 hydrogen. It's going to be Si and 4 valence electrons, H here, H here. Each one has 1 valence electron, and is going to bond to that 1 valence electron, like that. H can only share 1 because it only needs 1, and Si can share 4 because it needs 4. And then for sodium hydride, sodium Na plus and hydride, hydrogen H minus, same numbers, so they cancel. Elements in group 1 in column 1 are called alkali metals. They are reactive. We know that about alkali metals. And they react with elements in group 17, non-metals, to form ionic compounds. Metals and non-metals, ionic compounds. Elements between 2 and 13, transition metals. And they form colored compounds. That's a special feature about the transition metals. You have to memorize it, colored compounds. Elements in group 17 are called halogens. They are non-metals, and they can either share or gain electrons, so ionic and covalent compounds. Elements that belong to column 18, noble gases, non-metals, and they are highly unreactive. They do not share, they do not gain, they do not lose, they don't do anything, they're just في حالهم. Sodium and sulfur and argon belong to period 3. You have the periodic table in front of you, just see which period it is in. And sulfur, it's in group 6, so it has a charge of 2 minus. And sodium, it has the charge of Na plus. Sodium, Na loses 1 electron, while sulfur gains 2 electrons. Question 6. The chemical formula for sodium oxide is sodium is Na plus, oxide يعني oxygen, it has 2 minus, crisscross, Na2O, so it forms an ionic compound, metal for Na and non-metal is O, so it's an ionic compound. وبعدين sulfur dioxide, they gave you its name sulfur and dioxide, so just sulfur O2, SO2, dioxide. They gave you the name, they gave you the answer is in the question. And it forms covalent bonds to non-metals. The chemical formula for magnesium chloride, magnesium group 2 has a charge of 2 plus, chloride group 7 Cl minus, crisscross MgCl2. Again, metal, non-metal, so ionic bonds. The empirical formula for phosphorus trichloride, again they gave you the name phosphorus, so P, and trichloride, tri, the prefixes, tri, so 3, PCl3, and it forms covalent bonds. Select the atom that forms a covalent bond with Cl. So covalent bond, we need a non-metal. Na is a metal group 1, Mg group 2 metal, and potassium I think group 1. Yeah, group 1 non-metal, metal, sorry. So sulfur is the only one that's a non-metal, so it forms a covalent bond. The atomic number of third row elements increases from left to right, from metals to non-metals. Atomic number and mass number increase. And then the mass number of third row elements, blank from right to left. Careful here, they're trying to confuse us. It's from right to left, so it's the opposite, so it decreases. The elements on the left, again, anything on the left of the periodic table is metals. And Si is the only one in period 3 to form network solids. A halogen X2 reacts with an atom A by sharing a pair of electrons to produce a compound AX. Now I don't really remember the options, but they were something like NaCl and then another salt and HF. So المهم يعني for the salt it's going to have a metal, so it's not going to share a pair of electrons. No, it's going to take or gain or lose electrons, so immediately remove the metals and you only have HF left. Both non-metals, so it is sharing in a covalent bond. This question I explained it last week, but it's not coming, we don't have it in the material. When a covalent bond forms, a pair of electrons is shared. Always when covalent, it is shared. The product is a molecular substance. You have to memorize this. Covalent bonds make a molecular substance. You also have to memorize this. Fluorine is a gas, chlorine is a gas, bromine is a liquid, and iodine and acetine are solids. Isotopes are atoms of the same element, so same atomic number. But different mass numbers. Again, don't forget, it's different mass numbers, same atomic numbers. And locate the model that represents an isotope of hydrogen Z equals 1. Z equals 1 is atomic number. So this one has 1 proton, this one has 2 protons, so wrong. This one is correct because it has 1. This one has 1 proton, 1 neutron. So same atomic number, different mass numbers, correct. And this one just has a neutron, so wrong. The elements, given the following elements and their group numbers in the periodic table, choose the type of bond in each of the following compounds. KCl, K potassium is a metal, Cl is a non-metal, so metal non-metal is ionic. NCl3, nitrogen is a non-metal, Cl is a non-metal, non-metal non-metal covalent, N2, two non-metals, so covalent. This one also came last week. This one is really simple. Two chlorine atoms, Cl, they each have 7 valence electrons, so they need one. So they only share one pair of electrons, giving a single covalent bond. Two oxygen atoms, they share. See how many they need here, 1 and 2, so they share 2 pairs of electrons and a double covalent. Two nitrogen, they need 1, 2, 3, share 3 pairs of electrons and a triple covalent. The mass number of an element indicates the amount of protons and neutrons. Protons, neutrons, mass number. Locate the model that represents an atom of atomic symbol 2, 1. So it has 2 particles in the neutron and the nucleus and 1 proton. This one has 3, so it's wrong. This one 3, so it's wrong. This one is 1, so it's wrong. And this is the only one that has 2. Again, double check if it has 1 proton, so it's correct. The number of protons in an atom is represented by atomic number. Atomic number, always protons. Now they want the atom with atomic number 2. This one has 1, so it's immediately wrong. This one has 3. 1 is neutron, and 2 of them are protons, so it's correct. This one also has 3, but 1 proton, 2 neutrons, so it's wrong. We want 2 protons. This one has 3, 2 neutrons, 1 proton, so also wrong. Choose the diagram that represents atoms. So we want the protons and neutrons to cancel 1, A is an atom. These 2 neutrons, so they cancel anyways. P and E, the 1 proton, 1 electron, they cancel, so B is an atom. This one doesn't have any electrons, so it's immediately an ion, so wrong. D has 2 electrons, 1 proton, one of them cancels, we still have an electron left over, so it's wrong. And then E, the 2 neutrons cancel, proton and electron, they go together, 2 protons, 2 electrons, so E is an atom. So A, B, and E are atoms. Now choose the diagram that represents a positive ion. Again, ions are not atoms, so we just cancel out the atoms that we already have and we check for a positive ion. This one does not have any electrons, it only has a proton, so a proton left over, so it's immediately a positive ion. And then a negative ion, we only have D left over. That is not anything that we chose, so it's already D. Double check, 1 proton, 1 electron, they cancel, and then we have an electron left over, so it's negative. Fill in the table to determine the number of subatomic particles in the given ions. Here, without looking at anything, just looking at the symbol, I'm going to do protons first. Here, the number down 17, 13, 11, and 16. So Cl has 17 protons, Al has 13 protons, Na has 11 protons, and S has 16 protons. And after that, to get the number of neutrons, 35 mass number minus protons, 35 minus 17 equals 18, 18 neutrons. 27 minus 13 equals 14, 14 neutrons. 23 minus 11 equals 12, 12 neutrons, and 32 minus 16 equals 16, so 16 neutrons. Honestly guys, you don't need any help to do this, just do it on your own. And then 17 minus the charge minus 1, so minus 1, it's 18, 18 electrons. 13 minus 3, positive 3, 10 electrons. 11 minus positive 1 equals 10 electrons, and 16 minus 2 equals 18 electrons. The letter A in the atomic symbol represents mass number. This one is mass, this one is the atomic mass. So also common sense. We had this since last term, so you should know it by now. Letter A mass number, letter Z atomic number. Now the atomic symbol of bromine, they want the number of protons, electrons, and neutrons. Without doing anything, number down. Z is a number of protons, 35. 80 minus 35 is 45 neutrons. And then no charge, so same number of protons is the same number of electrons. So 45 and 35. This question we also had it last week. There is the rule, you should know it by now. It is molar mass 1 times percentage of 1 plus molar mass 2 times percentage of 2, and so on, over 100. So we have first molar mass 28 times 92.23. That's our 1. Our 2 plus 29 times 4.67. That's our 2. And then our 3, it's 30 times 3.1 over 100. I'll put it in the calculator. And then you get 28.1087. They want 3 significant figures, so take the first 3, check if it has 28.1. I'm not gonna teach you rounding. And then again, A is mass number, Z is atomic number, X is the chemical symbol. Here again they're asking for number of protons, electrons, and neutrons. Number of protons, number down, is 11. Number of neutrons, 23 minus 11 is 12 neutrons. This one has no charge, so number of electrons is the same as protons, so 11. And then this is an isotope of also sodium, no charge, so it's 11. So number of protons and electrons 11, and then 24 minus 11 is 13 neutrons. This one you have to memorize. Lithium gives a red, so Li gives red, Na gives yellow, and K gives a lilac flame. Now to the balancing. Now there are a lot of balancing questions in this quiz. They're really annoying, but you have to memorize some of them. مثلا an alkali metals and alkaline metal and hydrogen, they make metal hydride. So just balance and don't forget the what's it called? Yeah, the state symbols. So they want the reaction of sodium with hydrogen, Na and H2, Na plus H2. We know that any alkaline metal with the hydrogen gives metal hydride, so sodium hydride. Now balancing, we have 2 hydrogen, 1 hydrogen, so we put the 2 here. Now sodium is not balanced, so we also put a 2 here, so it balances everything out. And then write the ionic equation of the reaction that takes place between the products formed in part 1 and water. So NaH and water. Again, metal hydride and water. They're going to give H2 as in the gas, and then it's going to split the ions, the leftover ions, so Na plus, so metal plus, for example, and OH minus, hydroxide. Just you have to memorize this form, it's always like that. So it's NaH plus H2O water, it gives the hydrogen gas, the Na plus, and then we already took the H2, we have an H and O left over, so it's a hydroxide ion. We check if it's balanced. We have here 3 hydrogens, we have here 3 hydrogens, 1 sodium and 1 sodium, 1 oxygen and 1 oxygen, so it's balanced. And then for 3, Part 3. Write the equation of sodium and bromide. Sodium is Na plus, bromide is Br minus, crisscross, NaBr. Now we know the products. Now we just write the equation. So Na plus Br2 produces NaBr, and then we balance. We have 2 Br here, so we add a 2, and then the Na is no longer balanced, so we add another 2 here. And then part 4, write the net ionic equation of the reaction that takes place between the products formed in part 3 and water. Now when you put it with water, it's just a dissociation, so you don't really need to write the water. But don't forget the state symbols. I'm not writing it here, بس المهم يعني you have to write it, don't forget it. So NaBr plus water. You don't have to say water if it's a written part. If they ever give it to us written part, just write it on top of the arrow, and then it dissociates into Na plus ions and Br minus ions. A salt S is dissolved in water. When a silver wire is dipped into the solution of S, then placed in a blue flame, the color of the flame turns bright yellow. Bright yellow, the flame is yellow, flame test, so it's Na sodium. And when a few drops of silver nitrate solution are added to 2 millimeter of solution S, a white precipitate forms. White precipitate means Cl. So write the chemical formula of S. It's NaCl, or NaCl. And write the equation of the formation of the precipitate. They said they added silver nitrate, AgNO3, and we know that it only reacts with the halide ion, so the Cl. So it's Cl minus plus Ag plus produces AgCl. These two orders don't matter. المهم يعني you just write it. Don't forget the charges of the ions. A white solid M was dissolved in an aqueous solution Z. To a few milliliters of Z, a little chlorine water was added. The solution turned brownish. So we know now that after chlorine water was added, it turned brownish. So we have two possibilities, either bromine or iodine. And then when 2 millimeters of carbon tetrachloride were added in the tube and shaken, the CCl4 layer turned purple violet. Purple violet, we remove bromide, it's iodine. Iodine turns purple violet when CCl4 is added. When a platinum wire is dipped into the solution Z and placed in a flame, the color of the flame became lilac violet. Lilac violet, so it means that we have potassium. So now we have a potassium ion and an iodide ion, K plus, I plus, I minus, sorry. Same number they cancel, so it's Ki. And then they're asking what happens when silver nitrate is added to these substances. Again, silver nitrate only reacts with the halide ion in the salts, so just get rid of the positive ions of the cations. Now we have Cl, it turns white, Br, it turns cream, and I, it turns yellow. It's in the notes, you have to memorize it. Again, another balancing question. They want the reaction between chlorine and potassium. Potassium is an alkali metal, K, and chlorine is a halogen, Cl. So now we have the K plus Cl2 produces KCl, a salt that we know. Alkali metals and halogens, they form salts, so KCl. Now we balance. Here we have 2 Cl's. Here we have a 1. So we put the 2 to balance it, so it becomes a 2. And then K is no longer balanced, so we put another 2 in the reactant side to balance it out. So now it's 2K plus Cl2 produces 2KCl. Don't forget the state symbols. Now, Write the reaction between chlorine and hydrogen. Chlorine and hydrogen, so H2 plus Cl2. We know that it produces HCl. Or hydrogen with any halide or halogen, they produce an acid HCl or H halide. So yeah, so now we balance. We have 2 here, 2 here, so each of the reactants 2, so we're going to have 2 products, HCl, 2 HCl. So it's H2 plus Cl2 produces 2 HCl. And then part 3, write the reaction of the products when of the reaction in part 1 is placed in water. So KCl plus water, again here it's a dissociation reaction, so you don't have to write the water, you can put it on top of the arrow if it's written. And then it splits apart into the ions, so K plus Cl minus. And then last part of the question, part 4, write the equation of the reaction of the products when the product of the reaction part 2 is placed in water. Again, HCl is molecular, but when you put it in water it dissociates into the ions. So HCl plus H2O or water, or whatever you wanna call it, it's H plus and Cl minus. I know I said before that H is minus, but it has many. It's a special thing. H ions can be plus, minus, or they can share electrons. So it's something different for H. For now, you know that most of stuff when with water it disassociates, but not everything. For this question, you're going to need a periodic table beside you, or if you memorize the charges of everything, you don't really need it, بس يعني still. So sodium is sulfur, sodium is Na, sodium Na is a metal, and sulfur S is a non-metal. S is in group 6, so it has a charge of 2 minus, and Na is in group 1, so it has a charge of Na plus. Crisscross, so it's Na2S. And then magnesium with chlorine, magnesium Mg is a metal. It is also it is in group 2, so it has a charge of 2 plus. Chlorine is a non-metal. It's in group 7, so it has a charge of minus 1. Crisscross Mg2 plus and Cl minus. Crisscross MgCl2. And then aluminum with oxygen, Al is in group 3, 3 plus, and oxygen is in group 6, O2 minus. Crisscross Al2, O3. Then now silicon with oxygen, they're both non-metals, but when silicon reacts with oxygen you have to memorize it. It's ClO2. It's CiO2. It's a network solid, so you have to memorize it, CiO2. And then silicon with chlorine. Silicon needs 4 electrons, and it can share 4. It can only share 4. Chlorine needs 1 electron, and it can only share 1. So how many chlorines do we need for Si to have 8 valence electrons? Since each one can only share 1 and we need 4, so we just multiply it, so we need 4 Cl, so it's SiCl4. Now sulfur with hydrogen. Sulfur is in group 6, so it needs 2 electrons and it can share 2 electrons. And hydrogen, it needs 1 and can share 1. So how many hydrogen do we need for S to meet the requirements for 2 electrons? So we need 2 hydrogens علشان each one can only share 1, and we need 2 electrons. So it's H2S. Most of the time when it's non-metal and non-metal, so covalent bond, H comes first. And then last one, argon with hydrogen. Argon is a noble gas, so no reaction. And then part 2, sodium with sulfur, metal, non-metal. It is ionic, and it gives an ionic compound. And then magnesium with chlorine, metal, non-metal, ionic and ionic. Aluminum, metal, oxygen, non-metal, metal, non-metal, ionic and ionic compound. Silicon with oxygen, network solid. Best they have covalent bonds, and the compound is a network solid. Silicon and chlorine, non-metal, non-metal, so it's covalent bond and molecular solid or molecular compound, and so with the rest. And non-metal, non-metal, covalent bond, molecular solid. Argon with hydrogen. Argon is a noble gas, so it does not bond with anything, so no bond and no compound. Color is a flame red, it's Li, lithium, but careful, there is lithium and lithium ion, so what colors the flame red is the ion. That's why we dissolve the salt before putting it on the fire. So colors the flame red, it is lithium, Li plus, forms a cream colored precipitate. Cream colored means it's Br minus. Whenever they tell you blue crystals, know it has to do with copper, and then it becomes a white powder when heated gently. It becomes white powder when heated gently, so it is CuSO4, copper and sulfate. A dark grey shiny element that sublimes into purple fumes. You should memorize this. Shiny element and purple fumes, so it's iodine. Solution turns brownish when Clorox and acid are added to it, I minus. And least dense reactive gas, it's helium. Least dense unreactive is helium, reactive is hydrogen. And then last two, the least dense alkali metals. As we go down the group, the density of alkali metals increases. So it's lithium is a gaseous diatomic element that constitutes most of air, it's nitrogen. Another balancing question. So here in this question they gave you the what's it called, the reactants, and they want you to give the products. Now we know Ki and AgNO3, so a salt and silver nitrate. The iodine is going to bond with the Ag to give the yellow precipitate that we know, so it's AgI, and then the other two ions are going to bond كمان, فit's KNO3. And then Br2 and KCl, it is a displacement reaction. We check if Br is more reactive than Cl. In order, it's FCl and Br. Cl is on top of Br, so it's Br is not more reactive than Cl, so no reaction happens. And then H2 and Cl2 plus the spark, we know that it gives HCl. You just have to balance 2 and 2 and 2. After that we have the NaF and AgNO3. Fluorine does not form a precipitate with Ag, and NaNO3, I mean they react but nothing visible, so it just dissolves. And also Na and NO3 is highly soluble, so no reaction. And then Cl2 and 2Lii, lithium iodide, sorry. Another displacement reaction. We see if the Cl is more reactive than the I, so it's F, Cl, Br, and I. Cl is more reactive than I, so Cl displaces I and they replace each other. So now it's I2 plus 2LiCl. Don't forget to balance, this is balanced. H2 and 2K, so it's KH. When it's an ionic, the metal comes first before hydrogen. Again, most of the time, not all of the time. So yeah, it is. Don't forget to balance. Now NaH plus H2O. It gives the metal hydroxide and hydrogen. Again, don't forget to balance. You have to memorize this metal hydroxide and the hydrogen. When the metal hydride reacts with water, it gives the metal hydroxide and hydrogen. Now HCl plus NaOH, when an acid reacts with a base, it gives the salt and water. Now protons, neutrons, they each have 1 AMU, electrons have 1 over 2000 or 1 over 1800. The mass of an atom is approximately equal to the total mass of the nucleus. Only the nucleus, because you need a huge amount of electrons to make a difference. Chlorine has two stable isotopes, 35 and 37. Now, I already said the rule, so I'm not gonna write it again. I'm going to go into the mass على طول, the math. So 35 times x% plus 37 times 100 minus x%. These two x's, these 2% when you add them, they're going to make 100. So the x's cancel. That's what you do if they don't give you the percentage and they want you to find it over 100. And they gave you the average molar mass is 35.5. So now you do the mass. 35 x plus 3700 minus 37x equals 3550, and then it is minus 2x equals minus 150. X is 75, so for the 35 it's x, so 75%, and then for this 37 it's 100 minus x, so 100 minus 75 equals 25. Here they're asking for the reactions of alkali metals with chlorine, oxygen, and water. So with chlorine, the form is 2M. M is alkali metal plus Cl minus produces 2MCl. So here it is balanced, the form is balanced. So they're asking about potassium, K, so you replace the M with K, and that's it. Again, you have to memorize this. And then with oxygen, it is 4M plus O2, it's 2M2O. They're also asking about potassium, so just replace the M with K. And now you have it balanced, كمان. And then last one, the form is 2M plus 2H2O gives 2MOH plus H2. So here they're asking about potassium again, so replace the M with K, and that's it, and it's balanced. That's all of the quiz, and yalla, good luck.